Hi, I'm Shannon Seaver. Today we're looking at quadratic function applications. Specifically, we're going to solve some word problems applying quadratic functions. Okay, so here we have an area problem. A rectangle with the width of 2x plus 5 and a length of 3x minus 1 feet has an area of 250 square feet. So let's draw this out, this rectangle. And we have 2x and a 5 plus 5, and we have 3x minus 1. Let's multiply these out. We have 6x here and 15x, a negative 2x, and a negative 5. So if I combine my like terms, which are these two right here, I'll have the equation, it should be 6x squared. 6x squared plus 13x minus 5. And it told us that this area is equal to 250 feet, so I can set that equal to 250. So we need to find out what our x value is so that we can find our length and width. So I'm going to set this equation equal to 0 by subtracting 250 from both sides. And when I do that, I have 6x squared plus 13x minus 255 equals 0. Now that it's set up like this, I can use my quadratic formula and solve for x. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this case, our b is 13, our a is 6, and our c is negative 255. So let's put that into our equation. So negative 13, put that in for b, plus or minus the square root of 13 squared minus 4 times 6 times negative 255 all over 2 times 6. So if we put this into our calculators, we'll end up with negative 13 plus or minus the square root of 6,289 all over 12. And then we would have negative 13 plus or minus 79.3 if we take the square root of that, and then divide that by 12. So we'll have two answers. Our x could be 5.53, or our x could be a negative 7.7. So we need to actually put these values into our width and length to find what the widths and lengths are. So let's look at our width. So 2 times 5.53 plus 5, that ends up being 16.06. That's the first one. And our length will be 3 times 5.53 minus 1, and that ends up being 15.6. So those are our two possible lengths and widths. If I put the negative 7 in here, you know what happens is kind of interesting, is you end up getting a negative number, and we can't have a negative length. It doesn't work. So I'm going to cancel that out and say that's not possible, and same with the width. So this we're not going to use. We can't have a negative length in our rectangle. So our width in this rectangle is 16.06. Our length is 15.6. If you multiply those out, we get really, really close to 250. So we'll stick with these numbers. So now I want to talk about projectile problems. Projectile problems are in two forms. The first one is this one right here. Negative 16t plus v sub naught t plus h sub naught, where v sub naught is the initial velocity and h sub naught is the initial height. So when we're talking about projectiles, we're either talking about throwing a ball up in the air or a missile, and we're trying to find out what is the height at a given time. So this particular one, the -16 one, is in feet per second, and that's what we'll use a lot of. However, when we're looking at meters per second, our very first number, instead of -16, is going to be -4.9. So let's look at an example. We have a rock is thrown upward from the top of a 25-foot tower with an initial velocity of 100 feet per second. So we're dealing with feet in seconds, so we are going to use the very first equation. If it were meters, we'd use the second one. So let's write that out. We have h equals -16 t squared plus v sub naught t plus h sub naught. Now, our original velocity is 25. So if I'm going to write this out, it'll be h equals -16 t squared plus 25t, because that's our v, and our, oops, I got that backwards. It should be our initial height is 25. That should go for h, and our 100 goes for v. So let's rewrite this. This should be 100t plus 25. Okay, so this is our equation. How long does it take for the rock to reach its maximum height? Well, if we're throwing something up in the air and when it reaches its maximum height, we're actually looking for the vertex of the rock. So since we're looking for the vertex, let's use our axis of symmetry, which is -b over 2a. So b in this case is 100, so -100 over 2 times -16. So that'll be a -100 divided by -32. And when we do that, we'll get the following answer. We'll get 3.1. So it will reach its maximum height in 3.1 seconds. So that's the first question. Let's skip down to C. It says, what is its maximum height? So what is the y value at 3.1? That's our vertex again. Looking at vertex again. Except we're looking at the y portion of it. So if I take 3.1 and put that back into my equation, so it'll be -16 times 3.1 squared plus 100 times 3.1 plus 25. So if we put that into our equation, we get 488.8 feet. So its maximum height was 488 feet. When did it reach its maximum height? Well, 3.1 seconds. Next question is how long does it take for the rock to fall back to the ground? In this case, we need our x-intercepts. So we are going to use our quadratic formula to find that one. So our A is -16, our B is 100, and our C is 25. So if we put that into quadratic formula, we have -100 plus or minus the square root of 100 squared minus 4 times -16 times 25. That's all going to be over -2 times -16. So I'm going to pause the video here and put this into my calculator and come back with the answer. So in this case, we have two possibilities. We have a -0.24 or we have 6.49. Now if you think about matter of time, you cannot go backward in time. So this is not a possibility. So our only option is to have 6.49 seconds as to when it hits the ground again. So if you think about it, vertex, we're talking about maximum height and when it reaches that height. And then the x-intercepts are when it leaves the ground and when it hits the ground. So those are the two things that we're looking at in this type of problem. That is it for this video.